Hi all, Mike Landry here. In this brief video, I'm going to go over how to run Pearson's R and a Spearman's row using SPSS. Pearson's R is a test we use in correlation when both variables are in scale data. Spearman's row can be used when the assumptions for the Pearsons are not met or when we have ordinal data for both variables. So real quickly, I had an Excel database. I loaded it into SPSS, and I'm in the variable view. And so we have several different variables here. And for this one, I want to see if height and weight are related or correlated. So what I'm going to do is go to the top toolbar, click on Analyze, come down to Correlation, and I'm going to choose Bivariate. And all of our variables are going to be in the window on the left. And you'll find this for all of the SPSS tests. Our variables will be on the left, and I'll use the arrow to click them over. So what I did was I clicked on height, I clicked on the arrow and brought it over, and I clicked on weight and brought it over. I've clicked off Pearson's in this case because that's the one I want to run. But I'll go ahead and check Spearman's too, so we can do both of these at the same time actually. And I'll choose a two-tailed test. That's the one I prefer. Excuse me. You'll see Kendall's tau here. Kendall's tau can also be used with ordinal data, but typically it's used with a smaller sample. So we'll go ahead and click that one off. I just prefer to use Spearman's to make that simple. Select OK, and you'll get the printout. And up here we have the printout, the data output for our Pearson's correlation. And here we can see we have one for Spearman's and one for Kendall's tau. And you can look at this and see how they're very similar. So let me just cover one. Let me just cover the Pearson's. So let's do it this way. I'm going to drag my cursor over the output box until I get the blue square. I'm going to right click. Sometimes that doesn't work. Let me try it again. Right click, copy. And then I'm going to open a Word document. I have one under here. And I'm going to select Edit Paste. Okay, so here we have this data. And some of you asked about this, and we covered this in another video, but simply put, in APA, we want our tables to span from the left to the right margin. So what I'm going to do is I'm going to select the table. I'll go up to the top toolbar, click Table, Auto Fit and Distribute, and Auto Fit to Window. And you'll see that that'll be very nice in making this table span from the left to the right. And we don't have to do too much here. You can, of course, adjust the fonts. I always like to make my tables as small as possible in SPSS to conserve on space. So I would, if I was going to keep this table, I would change it into single space lines. I want you to notice something here first. We have our two variables, height and weight, on both sides. And if you look carefully at these boxes, you'll notice that we have duplicate information. And this is a very classical way of showing a Pearson's R, or Spearman row, or Kendall's tau. This is what we'd expect to see. To try to explain this, what we're looking at in this, I'll call this the top cell. We have height times height, and you'll notice that the correlation is 1. It's perfectly correlated. Of course, it's identical information. We'll also have an N of 100. This information is duplicated in this column, this last cell, for weight and weight. Then what we have is we have two cells where we've crossed height and weight, and you'll see we have the same numbers. In this cell we have, in this second cell here towards the bottom, we have a correlation of an R of 0.746, which we also have in the higher box. We have a significance, a P of 0.000. We also have it in the other box. And we have N's of 100 in both. And for this reason, my personal preference is not to put a correlation table in an APA paper because it just simply takes up too much space. Instead, what I would do with these results is I would write these out. And so the only important information here are these three numbers. We have an N of 100. We had 100 in our data set. We have a significance of 0.00, and we have an R of 0.746. And so what I've done here, and you can look at this, you can stop the video and see how I did this. I wrote this out in what I consider to be my preference for writing up results based on what I've found in the literature. And also because in an APA paper, we want to always remember that if we can state something more simply using less space in the text, that's the way we should go. If we can state something more simply using less space in a table, then that's the way we should go. So notice how I can write this little brief paragraph and summarize what we found in this correlation. Pearson's correlation coefficient was calculated for the relationship between height and weight for a group of CHF patients, or whatever the population is. A strong positive correlation was found, and the way we read this, we have an R with 99 degrees freedom, which is obtained by simply taking the 100 and subtracting 1, of 0.746, and a P of equal to 0.000, indicating a significant linear relationship between these two variables. Height increased as weight increased. And I think if you did that in this particular case, it would state this very well. And so if I was writing this up as a paper, I would delete the table. I hope this helps to explain how to run a Pearson's correlation. It would be the exact same process for running a Spearman's rho or even a Kendall's tau. I hope you've enjoyed this. Thank you.